What do you think? Should we talk about the way muscles are organized? Trick question. I don't care what you think, I'm going to talk about it anyway. So, muscle organization, let's start with stuff that we're familiar with. Let's back up to the skin. So if I were going to take a sharp knife, like the one I was carrying in my pocket, and if I were going to cut through my arm all the way, like that guy Aaron Ralston did, the guy James Franco played him in that movie 127 Hours, he was trapped in Blue John Canyon in southern Utah. I've been to Blue John Canyon, by the way. I didn't hike all the way through. But yeah, he was in the canyon and a boulder came and pinned his arm against the canyon wall, and he was there for 127 hours before he finally realized that he should cut his arm off in order to get out. So if we were going to do that, what would we cut through? We would cut through the epidermis first. 5 layers, you should know them. Stratum corneum, no lucidum here, right? Corollicus grani, stratum granulosum, stratum spinosum, stratum basale. Then 2 regions of dermis, papillary and then reticular, and then hypodermis. When we were doing the skin, we called it the hypodermis. Now that we're in the muscles, we know that in fact it is the superficial fascia. It's the connective tissue that goes around the very outer layer of all muscles. So the superficial fascia. Okay? Then the next we have a layer of deep fascia called epimysium. Epi on top of or above, mys, root word muscle. It's on top of the muscle. Its name says what it is. Epimysium, on top of the muscle. Then comes the muscle itself, covered by epimysium. Then next there are these groups called fascicles, and they're covered by another layer of deep fascia called the perimysium, peri, around. So these are fascicles, not popsicles. Fascicles, not popsicles. These are units of anywhere from like 10 to 100 muscle fibers. So what we see in muscle is we see units inside of units inside of units. It's like they have those things where you open a box and there's another box inside, and you open that box and there's another box inside. Muscles are organized that way. So the muscle itself is made up of these bundles of 10 to 100 muscle fibers. They are surrounded by perimysium. Then we get down to the layer of an individual muscle fiber, which is surrounded by endomysium, endo inside of the muscle, endomysium. And a muscle fiber is the same thing as a muscle cell, all right? It's not my fault. There's nothing I can do about it. They named these things before I was born. You just have to get used to it like I did. So muscle fibers or muscle cells, these are the basic cells that make up a muscle, obviously. There are lots of them in a single muscle. Then we're not even done yet. There's yet another box down inside, the myofibrils. Now sometimes people get these mixed up, but I know you're not going to, because here's what we're going to do to keep it from ever getting mixed up. What is a myofibril? It is the contractile organelle of a muscle cell. The contractile organelle. So remember, cells have organelles, the mitochondria, the endoplasmic reticulum, the rough ER, the smooth ER, the Golgi apparatus, the lysosomes, the peroxisomes. Those are all organelles. Well, muscle cells have an organelle that no other kind of cell has. It's called a myofibril. And it is an organelle that contracts, because remember, what are the 4 tissues of the human body? Epithelial, connective, muscular, nervous. And what is it that muscular tissue can do that no other tissue can? It can contract. And why can muscular tissue contract? Because inside of each individual muscle cell is a special contractile organelle that does the contracting. That's what makes muscle tissue so different. Muscle cells, muscle fibers have myofibrils. No other kind of cell has those. So the myofibril in turn is made up of 2 filaments, and they overlap one another. And we saw, if you've gone through that physiology PowerPoint at this point, the way the muscles contract is called the sliding filament mechanism. When the muscle contracts, the filaments slide past one another and the whole muscle shortens. So when you look at a muscle like biceps brachii, it looks long right now. What happens as it contracts? It gets shorter. that has to happen because as the filaments slide past one another, the entire muscle shortens up. So the thin filament and the thick filament, the thin filament is made of a protein called actin. And the thick filaments are made up of a protein called myosin. So myosin, the thick filaments, have these big golf club-like heads. And then there's a myosin binding site on each actin molecule. These are proteins. Actin and myosin are proteins. What happens is the myosin head grabs the myosin binding site on the actin, and then it does a rowing motion powered by ATP. And it's that rowing motion that causes the filaments to slide past one another. So there you go, the sliding filament mechanism. So look at all the layers here within the muscle. That's part of what makes muscle both flexible and strong, like the cables that hold up suspension bridges. It's not one solid piece of metal, it's lots of smaller units of smaller cables that give it strength and flexibility, which is exactly what you want muscles to have. They have to be strong, but they have to be flexible. They have to be able to bend, they have to be able to stretch and snap back and so on. So the epimysium, the perimysium, and the endomysium, again, these are all layers of the deep fascia, all right? So superficial fascia, same as the hypodermis. Deep fascia, remember, organize units, muscles of similar function into units. But the deep fascia, the epimysium, perimysium, endomysium, extend past the end of the muscle. And when they do that, they form a what? They form a tendon. That's why I keep saying that a tendon is really part of the muscle tissue. It's the deep fascia extending past the end of the muscle that then connect the muscle to the bone. Remember, ligaments connect bone to bone, tendons connect muscle to bone. So what does the tendon actually connect to on the bone? You know the answer to this. We learned it when we studied the bones. Connects to the fibrous periosteum, which is the outer covering that goes around. Underneath that, remember, was the osteogenic periosteum, where the stem cells are. That's how bones do appositional growth. They grow in width. But here we have the deep fascia extending to form the tendon, which connects to the fibrous periosteum. That allows the muscle to pull on the bone. And that's what's happening here. Muscles are pulling on the bone. That's how we move. That's why we don't have to stay seated in front of the TV all the time. We can actually move around. So there you go. That is the overall organization of a muscle. I'll expect you to know all these parts, and I'll ask you questions about them. So text or email me with any of your own questions.